Um, it's a great pleasure to be here to welcome Dr. Kasturirangan, and it gives me double pleasure because we have heard much of ISRO and what it did under his dynamic leadership, and we have been feeling it over the last 3 years, and his transformation of the intellectual and the administrative structure of the institute is something which has revolutionized what the institute has become, and the kinds of programs and the newer limits to the kind of work which we hope to embark upon. Dr. Kasturirangan is also originally a physicist, a cosmic ray physicist. He did his doctoral degree from Physics Research Laboratory, Ahmedabad, and he has made extensive and significant contributions to studies of cosmic X-ray and gamma ray sources and effects of cosmic X-rays in the lower atmosphere. As you well know, after his work in the cosmic ray program, he was a part of ISRO for many years, and for over near 9 years until 2003, he steered the Indian Space Research Program as chairman of ISRO. Under his leadership, the program witnessed several major milestones, the effects of which we see every day, including yesterday's very successful experiment of a payload coming back to Earth. He included the several milestones, including the successful launching and operationalization of India's prestigious launch vehicles, the PSLV and the geosynchronous satellite launch vehicle. Further, he also oversaw the development and launching of some of the world's best civilian satellites, IRS-1C and 1D, realization of new generation INSAT communication satellites, besides ocean observation satellites IRS P3 and P4. And we all know that if any sociologist of science looks at scientific institutions today, always count ISRO as one of the major success stories, not only as a product of good scientific work, but also as a scientific administration and the impact it has had on the science and its relationship to the larger society. And we are indeed fortunate that ISRO has seen a series of great leaders, and of whom Professor Kasturirangan was a pioneer among them. He is a member of the International Academy of Astronautics and a member of the International Astronomical Union. He's a member of very many distinguished boards, but I'm sure many of you would have read recently that he has been made an academician of the Pontifical Academy of Sciences, Vatican City, which is one of the rarest of the rare awards awarded by the Pontifical Academy of Sciences, where the honor is actually granted by the Pope. It consists of some of the most leading thinkers of the world, including many Nobel Prize winners among them, and is one of the most influential bodies on world policy in general. He's won several awards, which I don't need to list, but particular interest to us, since we come from different parts of the country, is being conferred with the highest civilian honors such as Padma Shri, Padma Bhushan, Padma Vibhushan, and also a very prestigious award of the Officer of the Legion d'Honneur by the President of the French Republic in France. Among his many invited talks, there are very important ones which he has been giving in the recent times. Some of the later ones include the 3rd Darbari Seth Memorial Lecture in New Delhi and the K.R. Narayan Oration at the Australian National University, Canberra. So it's a great pleasure to have a person of his intellectual integrity and dynamism to be with us, to talk to you, and particularly apt in a theme such as excellence in leadership. Dr. Rangan.
Thank you, Sundar, for those remarks. Professor Ramurthy, my colleagues, and esteemed participants. Sangeeta and myself, we decided that we will make this a little different from the type of lectures that have been delivered yesterday and will be delivered in the subsequent days and also today, by making it more interactive rather than trying to go through a 1 hour kind of a exposition of India's program or the strategy we adopted and so on. Because I think most of you in some form or other are familiar with this. In fact, space is widely publicized as an area of activity in this country. There is tremendous interest among the informed citizens of this country as to what we are doing in this area. And certainly there is an element of excitement and pride that comes out of what we have been doing. So with that kind of an assumption and a premise, I thought it would be much better that to spend time interacting between us rather than to go through a very major description of the program, it's what its details are, which I am sure that today in the era of information technology is not very difficult to get from whatever sources you choose to get it. And also we had in the morning a very authoritative lecture, I should say, by Professor Ramamurthy, because he really painted a very wide canvas of the issues related to science and technology management, particularly the intellectual capacity management in this country, the leadership for science and technology, and the criticalities that the country will face in the coming years as we try to move into the knowledge society, and the central role that science and technology will play with respect to the knowledge society and the development and the related development. So there was so what I tried to do is to really map those ideas into a single program of this country, which is the space program. Generally, most of the elements that he brought up in some way or other, whether it is related to IPR, whether it is related to science management, whether it is related to human resource, whether it is related to India's procedures and rules and regulations, in each one of them you will see that space has its own uniqueness in the way in which we did it. And belonging to a government organization, there is a general perception in the country that if it is a government organization, it has its own lethargy, it has its own bureaucratic approaches, and no decision gets taken in a timely fashion, accountability is rather poor, transparency is still poorer, and visibility is practically nil. So with that kind of a thing, you go with the approach as scientific department within a governmental framework. Obviously, I don't think that much can be done to change this unless we perform. So, right from the times of Sarabhai, one of the important things that we did is to make sure first be bold in taking decisions. So that is one of the aspects. So he had a vision which far transcended his times in terms of what should this country have as a science and technology approach for the grassroots level development. I am only trying to make some points, and you may like to extend it, take up cues from it, and also add your own ideas in trying to create a meaningful interactive session subsequently. So one was related to the vision, the formulation of the vision. And it was not a vision that was just given because somebody dreamt something in the night and then next day morning you came out with a vision. I had a dream and the dream became a vision and the vision became a mission. So it was not that kind of an approach that was taken. It was really a very well orchestrated evaluation of the various approaches that the vision formulation demanded. And I should say this is one of the very uniquely crafted vision for the country with respect to space, something which I don't think that in the case of science and technology we had. It was spread over something like 10 years. And the budget that we spent compared to say 2006 total budget that space has incurred from the exchequer taxpayers' money, it was only 0.6%. That is that first 10 years. But that formulating the vision, several strategies were adopted, and if you are interested, we could discuss that. Then it went through another phase, which was related to converting this vision into specific missions. But they were all proof of concept evaluation. It was not just directly plunging into a satellite program or a vehicle program. Every element of the decision had to be evaluated under the realistic conditions that are pervading in this country. So obviously we can't have a benchmark with respect to what America does or what Europe does. So we had to develop our own approaches to dealing with the space technology and its applications and related to the development. So this went through another 10 years of evolution. And the third phase, once having already focused on specific things, having emerged from the second phase of what I may call it as an experimental phase, we went into an operational phase where the space became a source of providing regular routine services in several areas of national endeavor. So this is the way in which the system has evolved. It took almost 30 years to 20 years to formulate, another 10 years to operationalize, and in the whole process, ultimately we have today what you witness as a certain space capability and the type of services that is able to render for national development and for other purposes. So this is one part of it. The second part of it is certainly what is today's core program, and you will see that I have in fact one of these lecture that I gave as a KR Memorial, Narayanan Memorial lecture, oration. If you had had a chance to look at it, it does describe some of these aspects, so we can take up a discussion on this lecture itself, the material content. So we have a brief description of what the core program. All I can say with respect to the core program is it is social, or mostly related to the social component of the country's needs. So that is the part of the core program: satellite building, rocket developments, applications, working with the user community. So the whole host of it, which forms this what you call as a core program of ISRO. The other aspect is how do you address the questions of technology. You know, these kind of technologies, whether you talk of satellites or even worse, the rockets, you don't get it from outside very easily. So you need to have a strategy to develop this within the country. So what kind of options that we could exercise to develop this? If you on one side decide that I will have a launch vehicle, I will have a satellite, and then go into the application, I am sure even today we may be struggling with developments. So obviously the space approach this entire issue of technology developments, technology options, buy build options, taking the services of other countries. We had a very pragmatic approach with respect to this, so that every milestone of the ultimate objective of the space is to introduce the necessary relevant services that it can offer to the country as early as possible, and not to be deterred with the scientific technological issues which can then come in the way of introducing a particular service and make it anachronistic at any point in time. So that is one thing where considerable thought went into, and the strategy of developing technology, deploying the technology, making the correct choices in terms of options. That was another major aspect that the space program has always addressed. Space program, I said, was applications oriented. In fact, our strength comes because of the large community of users in the country, and there are several dimensions to the users in the country with respect to the use of space system. They are ultimate judges of what we do or what we don't do. The success of the program is not based on an announcement by ISRO chairman that we have a very successful program today, I have flown this satellite. Out of the satellite will emerge images or communication system. Out of the communication systems or imageries will be the several users who will depend on it, and those users are the ones who have demanded a type of service which they have to be satisfied with. If it is an imagery, whether it has the right resolution, whether it has the right geometric characteristics, whether it has the right temporal characteristics. So the entire thing, ultimately they are the judges, and if they say they are dissatisfied with it, obviously the mission is having difficulties. So that is where we brought in a check and balance in the overall system by having a fairly large cross section of the professionals who use the space as one of the better options in providing their own services to the country, whether it is at the government level or the non-governmental organization, or more recently the private entrepreneur. So applications orientation is a very critical element of the way we have planned ISRO, and all through it has been dovetailed into the development of technology. So technology was not developed for the sake of technology, it was always dovetailed to an end objective which is related to applications. Science and other dimensions was another major aspect. The science put the highest demands in terms of technology. So really, if you want to, when you talk of a lunar mission, when you talk of planetary mission, when you talk of an astronomy mission, the type of pointing capability, the guidance capability, the navigation capability, you have to really step it up by an order of magnitude. So on one side you have science, which is a spirit of exploration, which I think is extremely important for enriching the society, even though the number of scientists may be small, but they have an enormous role to play in the context of societal enrichment. And then the demand they put on the technologies is another part of it. So obviously you upgrade the technology, you make quantum jumps in certain technological capabilities, that only science can put a demand. And this in turn will be reflected on the applications mission, so you improve the applications in terms of a certain technological capability. So it has got a kind of a cyclic effect on the overall system performance. So science is fully supported by ISRO in this context, the space science application. And I had the privilege of working with Professor Ramurthy on many of the definitions of the scientific application, because ultimately the Department of Science and Technology and many other scientific organizations do support the downstream activities related to the use of scientific data, creating institutions which can use science, and also write ultimately the papers which get published in the best of the journals. So that is another part. Then the other part of it is with respect to how do we marshal the resources in the country with respect to the space program. You know, the space program is not built as an in-house activity. Right from the beginning, we decided that if somebody could do a particular type of a job, it should be entrusted to them, and we don't do it ourselves. And this is particularly important in the use of industries. And it is good to note that a substantial percentage of our budget gets into the industrial system in the country. Something like 500 small, medium, and big industries support the Indian space program, and this is 15 years back it had happened. So this is another major element with respect to our policy in using the industrial base of this country. On one side, you don't have to build up the infrastructure and the human resource within the organization, less of those management headaches, which is typical of many systems. You keep on trying to do internally, you keep on recruiting people, you keep on creating infrastructure, and then blow yourself up because you don't know how to manage the total system. So you really truncate it and do what you have to be essentially done, and make sure that others do the job where they can do it as well, as good or even better than what you could do internally. So this is a policy which we, and at the same time we have also found that the industrial base has helped them because there is a quality demand, there is a professionalism, there is a timeliness, there is a question of keeping the activity within a certain budget. So these kind of a culture where you work with the industry, it also then percolates down to their other products, and though there is a spin-off with respect to when they undertake. In fact, there are countries where they have evolved a space program primarily because they wanted to upgrade the industry. If you look at the Norway's space policy, it starts with saying the primary purpose of Norway space program, otherwise they don't need communication satellite and remote sensing, they can get it from anywhere in the world. So, but their basic idea is to upgrade the industrial base of that particular country, and this is one thing which certainly this country has benefited by running the space program closely with the industrial participation. And there are several other linkages we can discuss about it. Another important thing has been the international cooperation. Right from the beginning of the program, the international cooperation has been a hallmark of Indian space activity. And you know, the Tumba equatorial rocket launching station came into picture primarily as a product of international cooperation. Several countries cooperated in setting up that station, whether by supplying rockets, supplying computers, supplying helicopters. So these were all a part of an international. But today, it is not that we are just on the receiving end. We work as equal partners with several countries across the world. On one side, it of course improves the relation between the scientific community, interact with them, and therefore upgrades your own way of thinking and looking at issues. So this is one aspect of this kind of a linkage. Second is certainly it has a political overtone. When you try to cooperate with another country in space, certainly there are more than just being a technological cooperation or a scientific cooperation. There is a geopolitical component that comes in this kind of cooperation. This has not been lost sight of by the Indian policy makers in the context of forging relationships with other countries in the world in the context of space. Budget and the other things, financial management of the programs, I'm sure if you are interested, we could discuss about that too. Another important area is the project management, the program management, and the way the organization is structured. So that you have a devolution of the powers of management at different levels. It is not controlled by a single person. If you really very carefully look at the chairman's own powers, he is very limited financially. In fact, most of it is, as soon as he gets the budget for the organization, I think his job is over. It's all done at the lower levels. So this is a very unique system which has been established right from the days of Vikram Sarabhai and subsequently Satish Dhawan. And this is followed very, very scrupulously because we think that power, responsibility without the appropriate financial and other kind of powers, whatever may be the levels, has no meaning in the overall management of systems. That also puts in accountability, and there are something like 6 to 7 levels in which financial powers are today entrusted with, and that helps the organization to run in a manner which otherwise would have been extremely difficult. We have, of course, other kind of interesting thing. One is, of course, the questions continuously keeping in regarding the strategic capability. What does this all technology mean? Does it have extra implications with regard to national security and many other areas? I think there is interest. We could discuss that aspect of it. And then when we work with users, I said that we have a large body of users in the country. Now, of course, as I said, it is not only government, but also non-governmental organizations and private entrepreneurs. But with this kind of a user base, what is the kind of an institutional framework within which the organization works while dealing with these organizations, whether it is within the governmental system or outside the governmental system? Very unique ways in which we could work together has been instituted right from the days when Satish Dhawan was the chairman, and many of them are today also still relevant, and we carry forward even though we have made changes both with regard to the institutional framework and the policy framework regarding the private participation into the India's space program. And the last couple of things that I would like to say is on the public outreach. We have a fairly systematic way in which we try to share the information about the programs with the public in an era where the right to information has been now enacted. I think this is something which has been always practiced by the Department of Space. I don't think that there has been any secrecy in the type of work that we have been doing at any point in time. Whether there is a failure of a launch, whether there is a success of a launch, the press is taken into confidence within hours. So that is the kind of, so there is a level of transparency, and also our program, major programs, not only with regard to success or failures of launches, but many of the details of the program and many of the other ways in which we have tried to make sure that our things are properly understood. The latter thing is to institute studies by independent bodies about our performance. For example, more recently, we did entrust to the Madras School of Economics a very detailed study of the cost-benefit analysis and the economics of the Indian space program. Very interesting study which is coming now. There is more, I think within a month or two we will have it as an Oxford University Press book undertaken by Professor Shankar and his people from the Madras School of Economics. This is just to tell you the amount of care we have taken in ensuring that the taxpayers' money, we have a proper way to account for it, not only in terms of program, not only in terms of missions, not only in terms of applications for development, not only to encourage science and not only encourage strategic capability or international cooperation, but also there is a quantitative assessment of the effectiveness of the program vis-a-vis alternate options. You know, one can always ask this question, why space? We could do this with a ground-based system or an aerial-based system. So we need to have a proper assessment from the economics point of view. More recently, this is something which has been of concern to us, particularly because our budget has been growing. It is now something like 3,500 crores to 4,000 crores per year. So we cannot just keep quiet and say that this is one more way to do things and leave it at that. And then, of course, we have been constantly worrying about what should be the future of the program. We can have a little discussion on this. I thought that these are the few things that I will bring it to your notice and set this kind of a thing that we could now interact for the next half an hour or 40 minutes. Unfortunately, I have to leave at 12:30. So if we could restrict the rest of the interaction for the next up to 12:30, it would be appropriate. So I leave the floor to you to raise questions or clarifications or observations, whatever you'd like to do.
Thank you, Dr. Rangan. As he said, we would try and wind up our discussion part of it by 12:25, and then we'll have the formal vote of thanks since he has a meeting at 12:30. So please, the floor is open for discussion, and as we did earlier, if you have your, we'll start with Mr. Tyai.
Dr. Kasturirangan, so you gave us a very good view of what ISRO is doing from different angles, you know, cost, benefits, and the outlook from the common man's perspective. Now, I'm sure this effort would have taken the involvement of a lot of groups in the industry, in the country, and in some ways maybe from overseas also. Can you give us some idea? I just want to make an appreciation of the extent of the indigenous content from our industry in this space program by way of whether it's the airframe or the electronics or the various control systems, hydraulics, pneumatics, etc. To get an idea of the capability that is there prevalent here within the country and what is not prevalent, maybe we are getting it from cooperation from international agencies, because there are interlinked industries and challenges that have been posed by some of my colleagues here in aircraft building, shipbuilding, and such other complex initiatives that this country is taking.
Yeah, I think first I should say that we have a self-reliant program as distinct from indigenous program. You know, when you talk of self-reliancy, that we can conduct our program notwithstanding the vicissitudes of geopolitical situations. So, but that is all that we have made sure. Now, what does it lead to in terms of the actual situation? One, we need components, whether it is electronics or whether it is mechanical or other chemicals and so on. We need also materials. Materials are critical for space program. We have over the years tried to reach a level of self-reliance, self-sufficiency in these kind of components and materials. But we are not 100%. The reason, if you ask me, is not because that we cannot undertake those developments. You take the case of integrated circuits, or you take the case of processors, or you take the case of certain type of materials which are needed. Ultimately, the space program, even if we are going to go to 10,000 crores, in terms of the value of these materials and components, it is going to be a very small quantity, and is not going to be very attractive for entrepreneurs to invest money which is large. The demands are high in terms of quality, the returns are going to be poor. So whenever there is investment which is not, wherever there is a demand which is not commensurate with the returns that you will have for the investment, there is always this question of whether we should do it in the country or not. So we have made sure from the market surveys across the world that we can buy this, and it's much more economical to buy those kind of components and materials from outside rather than to make it in the country, because there are not many entrepreneurs willing to come forward and do this. This is one aspect. The second aspect is these are actually ultimately the word, the space system means design, development, system engineering, fabrication, testing. The value addition comes from this. So if I have a satellite and I spend say 50 crores on components and from outside, and I spend say 30 crores or 40 crores of components and materials from within India, this 50 or 60 crores of components or materials may sound quite large. But if you ultimately convert that into a satellite, which is it's our design and our development and our fabrication testing, if you look at that part of it, that satellite will cost you in the international market something like $200 million. So you see the gap between the value of the components and the value of the ultimate product in the context of what we do. So you have to look at it from that point of view. So this is one part. So that is where the indigenization is used rather pragmatically. It is not that we are fanatic about doing everything in the country and put ourselves with a wall from which we are unable to break out. So this is one. The second thing is with respect to the industrial thing. See, industry has perfected quite an amount of manufacturing process, assembly process, testing process for us. For example, today, if you ask me about the liquid engines of rockets, it is totally done by two industries working together in cooperation. So they virtually start from the basic materials to shaping the materials, to welding the materials, to assembling the materials, and testing the system at subsystem level, and then assembling them into a complex engine. This is done totally by the industry today. So you don't have that kind of a load coming to ISRO because it's done by the industry. And the industry here not only means private industries, but also the public sector like the HAL, Bell, and of those kind of things. HAL does very large amount of work. They have an aerospace division currently, which is only involved with satellite structures or vehicle stages and things of that kind. So they participate. Now what is the sum total of this? We spend something like 60% of our launch vehicle program budget, which is roughly about 30% of the 30 or 35% of the overall ISRO budget that gets into the industry. So you can see that it's a very substantial component of a program budget that goes into the industry in terms of supporting the industry to conduct this kind of work. In the case of overall program of the ISRO, I said even at 3,500 crores or 4,000 crore level, we are spending something like 45% of the total budget among the industries. So the industry is today capable of developing most of the system requirements of ISRO, and rather building the most of the system requirements of ISRO. Developing still is done. Critical technologies we develop, we transfer the technology under certain conditions and process, and the industries undertake. Even companies, a sugar company in Andhra Pradesh, in Tanugu, they do the hydrazine, the UDMH, the unsymmetric dimethyl hydrazine, as one of the fuel for the rocket liquid engine. So you see that the development was done by ISRO. They demonstrated how a sugarcane industry, the output of the sugarcane industry could be used for developing the UDMH, and today they supply to our stringent specification the UDMH from that sugar industry. So that is the level to which we have gone today, and I think it's a very satisfying relationship between industry and the ISRO that it has developed. And as I said, about 500 industries is not a small number. Managing them has been initially we had quite a lot of problem because you have to bring them to a space culture, and documentations have to be perfect. We have good documentation. Doesn't mean that the industries have the worst documentation. They try to cut corners sometimes, but that has been all changed over the years. And today you have a good system, a good method of documentation, good communication systems, and they develop with minimal amount of rejection rate. So the cost and economics is quite attractive with the industry, and that way ISRO has been able to optimize its own resources to areas where you need to hire. And in fact, the trend in the overall manufacturing, the growth of the manpower also in the recent years is to ensure that you add higher end manpower. Don't ever add a technician or a fitter or a welder into the ISRO system today. This has all happened in the early years, but we are changing everything today, and we are making sure that ISRO will be only at the highest level that they will try to do the work and entrust the rest of it to the industry and many other organizations in the country.
Mr. Ram. Number two, the second question is a little more deeper, in the sense that in the present day context of competing resources for manpower, how do you manage your manpower issues? One, from the point of view of recruitment, and secondly, being a government organization subject to various pressures in terms of preferences, etc., etc. I hope everyone understands what I mean. How do you really manage? And despite these kind of pressures, if you have been able to demonstrate the kind of visibility and success, what is the secret of that? It will be interesting for us to know, because we also manage huge government departments.
Okay, first is the lunar mission. You know, in the evolution of any science program or technology program, a time comes that you always think, what is the next? We have done this in applications area, whether it is position location to global positioning systems or things of that kind in applications, or improving the satellite's capability to look at closer and closer with better resolution. Cartosat 2 is an example of a better than 1 meter resolution camera systems we have. Science has been also equally exciting. In fact, science is more exciting than any of these when it comes to satisfying the intellectual capacity of the intellectual needs of the country. And we often debate among the scientific community, and mind you, ISRO is not a part of the, it can cater to the scientific community. It has a limited amount of scientific community, but that is not the total. So the scientific community is a larger community. You have a set of institutions under DST, under Professor Ramamurthy, which you cater to science, like the Raman Research Institute here, or the Indian Institute of Astrophysics in Bangalore itself. So the question is, what is the scientific community looking for, and what is our capability technologically, and what is the marriage that can come in where the scientific community's demands and aspirations could be satisfied. So it is in this connection we did a lot of exercises. We keep on doing exercises on this, and whether it is a planetary mission, whether it is an astronomy mission, whether it is a solar mission, whether it is a near Earth orbiting mission with respect to Earth's environment, we keep doing this kind of exercise with the scientific community to see what kind of things we could turn out within certain time in terms of scientific goals as well as in terms of a certain money being allotted. So the lunar exploration is interestingly one such outcome. But you know, if you throw this open directly to, here we adopted a little different strategy. And since you have a copy of this book, and there is a set of block diagrams in which I have tried to give you the evolution of the lunar mission, which took us 4 years to ultimately get the approval of the government, we adopted a little different style. What we did is we tried to point out the capability of ISRO in a very broad public lecture, which is public lecture in Delhi on the eve of the second technology day, that is the year after the first Pokhran explosion. I think it was on February 13th or something like that, May 13th. So at that time, Professor Murali Mohan Joshi, the then H.R.D. minister, told me to give the talk as the first technology day lecture. So we debated internally as to what is the best way to make an exciting talk, because that day it will be attended by the best scientists in the country in Delhi. It will be also by policy planners, members of the political and community, then industrial community, and many other informed citizens of Delhi. They were all a part of that crowd. So what is it that you can address to them? So we put in some, after giving a little background about India's space program, some of the important critical elements of the program, we also put in this, that we have reached a level of technology in satellites, we have reached a level of technology in rockets, which if you translate it into an interplanetary mission, these are the various possibilities. I can take with PSLV a 500 kilogram craft into the lunar mission orbit. If you try to use a GSLV, I can put as much as a ton into the lunar orbit. I can go to Mars and I can put about 300 kilograms of a satellite, or 200 kilograms if I go further down into Saturn, Jupiter and so on. So all those calculations, and we showed all those kind of a thing, and just to try to show that today we have reached a level of maturity in technology and conduct of missions which is ripe enough to undertake bigger challenges. That was all that the message was given to the public, this thing was. But the reaction next day was phenomenal in terms of the people show interest and the type of reaction we got even from media. So, but you don't take this as the ultimate judge of the whole thing. So we conducted several steps to look at it. What is there to go to a moon? What does it mean? We had a meeting with the Academy of Sciences in Lucknow, where the creme de la creme of scientific community, they meet every year. And you use this forum, about 800 of those academicians, they are the best in the country to judge the scientific merit of a program. So we made a half a day presentation at that academy meeting. And there was a unanimous opinion from the scientists that it is time for India to undertake something ambitious, which can provide a pride and which can also have a scientific merit. And the scientific merit part of it, they came into picture primarily because the lunar missions could have been 50 to 60 missions could have been conducted. Most of them are in the in the equatorial region. Very little is known about the moon with respect to the poles and other parts. It is like trying to derive information about the earth by just looking at the equator region and then forgetting that there is a pole or there is a temperate region and then model the earth. That's just not possible. So obviously similar thing is applicable. So the last word has not been said at all. In fact, the mission so far about the moon has raised more questions than answers with regard to its origin. So two fundamental questions today remain unanswered about the moon: the origin of the moon and the evolution of the moon, both. And the moon's geological activity stopped almost 1.5 billion years after its formation, which was about 4.3 billion or 4.4 billion years back. So what the moon has been left there as a pristine body after 1.5 billion years of origin, and everything has been happening to it in the near Earth environment. On the Earth, we don't have a way of getting information simply because of the fact the Earth is geologically active, it gets churned, and so the signatures get wiped out. Whereas in the moon, you have still those signatures left. So there are several interesting possibilities. One of them is helium-3, for example. The solar wind continuously blows. The sun has got plenty of helium. The helium-3 gets deposited. So there is somebody who asks, why don't we try to see whether we can helium-3, which could be a panacea for the power problems of the Earth, whether it could, on the long term, whether that could be an area. The questions of settlements, water. The answer has not been. There have been very conflicting observations regarding the presence of water, and therefore whether there is a permafrost kind of a situation in the moon, particularly in the polar region, which after the formation has never seen the sun. The lunar, the rotation axis and the revolution around the Earth, and the Earth's rotation around revolution around the sun. The geometry is such that the poles do not see. So obviously they are still the coldest regions in the solar system. So with this kind of a thing, quite a number, and then the technology of moon exploration has been at a certain level, which over the last 10 years has substantially changed in terms of sensor systems and observational capability. So it puts you in the scientific side with a tremendous possibility of revisiting, re-exploring, and providing a one order of magnitude or even better amount of scientific information regarding the origin and evolution of the moon, and also to answer some of these basic questions like water and helium-3. So this is the scientific part of it. Second is technological maturity. As I told you, it's a challenge. You need to really go one order of magnitude higher in terms of control, guidance, navigation to reach the moon. It may be a 4.5 day journey, but nevertheless you have a very big challenge in terms of technology to ultimately, within 20 to 20, in a 5 days journey, if you don't reach the moon in the 25 minutes, if you don't time it and put it in the right point with respect to that, you may miss the moon. Because the spacecraft may come and the moon may not be there. So to capture the moon has been one of the most difficult things. There is a lot of challenge. And like yesterday what the ISRO did, and Dr. Dekne is here, he developed some of the control systems for that. So that is another kind of a thing. Then the third part of it is, this world is very ruthless when it comes to putting cutoff dates. And if you don't do certain things within a certain date, then you create an international convention. And then you say that since you have not achieved this, you are not capable of achieving, and please don't do it, and you are not a part of our club. So this, India has faced this in other areas. So I don't think with India's capability today and with the economic growth that we are witnessing, we should be left behind other countries in the context of exploration. We should be able to make our own decisions on exploration. We should be able to make decisions on our own decision on whom to collaborate with. And they should be interested in collaborating with us because you are a player with whom it is worth playing game. So that is another third important thing. And lastly, what are the things we need to offer to the new generation? See, there's the youngsters. They all want to be fired with what is India, what is the great thing that we are doing. And I found after that lecture and after some things appeared in the paper, the number of emails we got from particularly the youngsters was unbelievable in terms of the interest that they showed about this kind of a mission. So I think all this adds up to the type of answer I can give you on this. Strategically, it is only with respect to the capability to reach the moon, which is certainly an order of magnitude more demanding than what currently we have in terms of the various technological elements, including space communications. So that's what has triggered off. The whole idea is to make sure that this is not a single one-shot affair. We will have a series, it will have for the moon, and this will also take us to other kinds of planets, Mars and Jupiter or maybe Venus this side. The question is the scientific interest and the type of things that the science would like to do. Technologically it's still possible, but ultimately in the 21st century, we should be a very important and key player in the global interplanetary exploration, which whether one likes it or not is going to take place. America is going in a big way, Europe is going in a big way, China is not going to be left behind in this kind of a thing, and India cannot be sit and watch helplessly on this kind of a thing. We are taking all the precautions to make sure about it. So, and the resources that is needed right now is about 300 crores, out of which 100 crores is for a ground station, which is a deep space network antenna, 30 meters antenna. So really we are spending 200 crores for the first mission. I don't think it is very, very substantial for the type of benefit that it can reap, even scientifically. So that is it. The manpower part of it, I think one of the things I said is that our requirement is about 600 to 700 good engineers every year. We have the first phase of ISRO's manpower addition was primarily from IITs and IISC. So in fact, most of the leaders today, if you look at them, they all were products of IITs and IISCs. But the second generation leaders who now head programs and projects, if you look at them, they are all from National Institute of Technologies and many other institutions, even local colleges and so on. We found that once you give the proper orientation, they are no less than others. So that part of it we have no problem. So, and we produce so many engineers that has not been a problem to orient them into this. There was a period in the era of IT demands where there have been some attrition, but in a specific areas like computers and so on, communications, but not in all areas. For example, the mechanical engineering became a problem because many institutions were not drawing mechanical engineer, they are all opting for the other one. Otherwise, getting mechanical engineers themselves, if you get them, was never a problem to retain them within the organization. So that part of it was still taken care of, but we did go through that. But currently, ISRO is certainly considered as a good opportunity to work in exciting area. That is what is drawing the youngsters. We have been recruiting at the level of something like 300 to 400 engineers per year. They have been of good quality. And we have also introduced a system of training and orientation, which takes place about 6 months to 8 months or so. They go around the centers. So this is the third part of it we have done. So, and also lastly, as I told you that we only want to add the higher level people who are interested in designs, who are interested in testing and development. So we would rather look for masters, more master degree people and PhD degree people, rather than to look for, and much of the job markets are for the bachelors, because the industries and the private entrepreneurs don't want to pay that much for masters and PhD. So we would look for that. So our challenge is, with whatever Professor Ramurthy says, we need to have better, good, high quality master degree people and PhDs coming out of the various institutions. Good thing is also there is interest among the people who have settled abroad to come and work in India now. Beyond 45, 50, many of them would like to come. We have a very simple way to recruit them. We can even ask somebody, a senior engineer visiting US, to just talk to them, and if he's found okay, offer them straight away. We just made such a this thing. On the other part of it, which is related to that we have to give certain types of preferences and so on. So far we have not been. Certainly we subscribe to all those philosophy, but we have made sure that our interests are protected, and that is the bottom line with respect to recruitment policy.
Mr. Arora?
Sir, you underlined that in the area of international cooperation, of course, a paramount factor naturally is how different countries perceive their national and geopolitical and strategic interests. Well, if I may say, I think international relations also have their own distinctive quantum mechanics, and over a number of years there is, I think, at least one can attempt certain statistical or probabilistic types of conclusions, if I may, with regard to which among the international partners have been more reliable than the others, or which have been more unreliable than the others. So here, over the decades, sir, as India's space program has evolved, well, what is your assessment about the relative dependability of different international partners, and also certain remarks which you may wish to give about our cooperation with other countries, particularly in terms of the extent and the dependability in the years to come? Thank you.
Well, one thing we are very clear in space, we can't depend on anybody outside. We work with that premise. So it's very clear to us, there is nothing like we have a permanent enemy or permanent friend in the international arena so far as cooperation with the space is concerned. The cooperation is always facilitated in space because of a broader, as you know, a broader geopolitical consideration. If Brezhnev tells Indira Gandhi that I would like to fly your man in space, and Rakesh Sharma gets selected, and ISRO says that no, we don't want to get into manned flight at that point in time because Professor Dhawan doesn't feel so, the political decision can still be that no, we will have a person, because that improves the relation between Russia and Soviet Union and India. And if that is done between Madam Gandhi and Brezhnev, you don't have much of a thing. So you see the character of this kind of a cooperation, there is something which is political. And today the same Soviet Union, which is now broken up, you try to talk to them, you talk to them only on cross commercial terms. And they have found out the catalogs of American catalogs, try to equate them. You know, in the earlier time also they used to have American catalogs. If they sell you an MiG MiG-29, they will say whether it is equal to F-16. So MiG-29 and F-16 are equivalent. So the MiG-16's price is equal to F-16 in the international market. For India, there is a plenty factor, which could be 0.1. So you multiply it by 0.1. For China, it could be 0.3. For some other country, it could be 0.6. And some other country, they can still sell it, but at the same cost price, at the international price. So Soviet Union used to fix up the prices, not based on their consideration, but by considerations of what America sells to the global market. So today they are coming to that. The friendship factor has disappeared in most of the cases. The question is, certain technologies are more easily available because there are a surfeit of technologies floating in Soviet Union. The earlier Soviet Union had an enormous amount of duplicate development strategies, and there are several centers of excellence which do similar type of a rocket engine is developed in 4 areas of this thing. An aircraft engineer, all those designers, the Tupalo, the McCoy and Gurevich, or Antonov, they were all schools, huge schools of development of aircrafts. So they were all available today. So they are trying to make speedy money. So the whole question is how much you can pay and get. So that is where the technology stops with today's Russia. When we bought the cryogenic engine, they gave us a certain thing. But today if you go, you can't buy a cryogenic engine less than what the international costs are, the one that was quoted to us by General Dynamics in US. So that part is very clear to us. So we are today working both with Russia as well as with America. America has also pitched in. We are having a much better relation with them. We are able to go and get instruments and things of that kind which we could not even think about, say 7 or 8 years back. They are going to fly 2 instruments in our lunar mission. So what does it mean? When you work with them, you get to know what kind of things we can do with them, and you get more sometimes. And so the relation is now scientifically there are such relations. Commercially with America, there is a question of procurement. And even when relations were there good with Soviet Union, we did have a reasonably good relation on the commercial side with America. We bought the first of the 4 INSATs from America. So those kind of a thing. And then with Europe, we had a much more steady relationship in terms of procurement, in terms of components, in terms of materials. The European prices are fixed based on the international market demands and availability. So they have a good intelligence system. So they know what is India looking for and at what price they can sell it, and we will be forced to accept those prices. So they know that. So that is really commercial. So between the 3 today, the Russia, which was the earlier Soviet Union with whom we had good relations, they did give for political reason free launches and other thing, but today there is no free launch. There is no free lunch and free launch with the Soviet Union. So today that relation is purely turning out to be commercial, but they are easy to get technologies from, simply because they have a large number of options available with them. We have Europeans who have been steady and we still work with them in materials components. With the United States, this newly opened up possibilities we certainly would like to take advantage of. After all, it's a powerhouse of technology, US. So I think we have to now learn to work with all the 3 sources of support that we need for our program. Parallelly, we are making sure that any perturbations in relation of either one or the other, we become transparent by ensuring that we also do our homework internally. We don't say gaga over getting everything from outside and we have a successful program, therefore forget about what we want to do inside. So we have been careful on that too. So there is an indigenous component of the activity. So this is the 4-pronged way in which we are managing our relations, both internally and outside.
We are coming close to 12:25. Can I take a brief question from Mr. Tandon?
Sir, my question pertains to the telecommunications area. We have seen a lot of explosion in telecommunications, but still the tel density is very low. And given the spread of the country, satellites can be used for the subscriber access in a very effective manner. I would like to hear your views, how effective it can be, and then what can be the large scale availability for this technology that can be used here.
I have a feeling the way the terrestrial systems are developing and also the optical fiber communications, which is not very far off, between the two they could be a very stiff competitor for the space communication in the conventional sense. But there are certain niche areas where space will continue to play a role. One is the very small aperture terminal, closed group users. If Reserve Bank has to have all its, State Bank has to have its all users, accounts closed by 3 o'clock, and if they want to network all their branches all over the country, they will have a closed group using VSAT, which we provide for. So these kind of specialized communication is one area where this will continue. The second one is the remote area communications, where again the kind of equivalent to VSATs, we can install it very fast in many, for example, Northeast. And today also the Andaman Nicobar Islands with respect to the mainland, or Lakshadweep Islands with respect to this. So here again, inaccessible areas or far-flung areas which are not easy to access and install the telecommunication infrastructure is a second set of locations that the satellite-based communications could be there. The third is emergency communications related to disaster management. because that is the first thing that fails in any disaster affected area is the communication system. So that is where we can easily fly a VSAT, establish satellite. We did that in the case of tsunami affected thing in the Andaman Nicobar Islands. So this is the third type of things. So this is very specific, and of course there are other kinds of things on which we will use the telecommunications thing as a supplement to complement to the existing terrestrial system. But I think that percentage is going to go down with time, and this is going to, and the personal communication like that one that has been developed for the West Asia, Thuraya satellite, could be another way, because then we need to make powerful satellites with multiple beams, and we can directly communicate with the handheld systems on a satellite based thing. That is still not very much in favor, because the terrestrial systems are still very competitive. But we think that could be another area, but we need to deploy 15-16 meter antenna in space and very powerful transponders, and then you can use handheld system. You know, the Motorola tried that, but it was well ahead of its time, so the whole system failed. So that is not, right now we are not thinking about it, but developments of the various enabling technologies, multiple beam forming, beam switching, large area antenna deployment, on this the research is going on in ISRO to ensure that when the time comes and we are with time and not ahead of time, we should be. And also we are working on some concepts which we will launch it with our GSLV as a test bed for evaluation of some of these concepts for the future.
We have run out of time. I apologize to those who had questions, and I hope we'll have opportunity to talk to Dr. Rangan over the course of the week. Can I now request Mr. Dekhani to propose a formal vote of thanks?
Respected Chairman Professor Sundar, Professor Ramurthy, Dr. Kasturirangan, Director NIAS, Organizer Dr. Sangeeta, and my friends, very good afternoon to all of you. It's my great pleasure and a great honor also to be in front of you to propose vote of thanks to our Chairman, ISRO Chairman and Director Dr. Kasturirangan. Today, ISRO's programs are taking leaps and bounds in terms of operational vehicles, re-entry vehicles, and the moon program, etc., and is very well respected internationally. It's all due to the concept put forward by founder Dr. Vikram Sarabhai and our chairman like Professor Satish Dhawan, Professor J.R.D, and Dr. Kasturirangan. I think it is a great thing to have a great leader for an organization who gives not just vision, he pursues that, he poses technological challenges and inspires people to take up that and work for that. And that is what Dr. Kasturirangan had been doing as a director of ISRO Satellite Center, as well as subsequently as a chairman of ISRO. I had an opportunity to work under him, and that is why I feel very proud. Today, whatever SRE space capsule recovery experiment we have successfully flown, it was all conceived during his chairmanship. It doesn't stop only by defining a program. Each and every step is well reviewed by different levels, and chairman is not only an topmost authority, he will be reviewing each and every technical aspect of each mission, and he knows much more than all of us, and that is where he gives a wonderful guideline at various junctures, junctures where we face certain problems and so on. And examples like cryo technology indigenization, similarly the induction training program of our young engineers, These are all the things which our leaders had been starting to make the organization grow and be a national or international player. I take this opportunity to propose vote of thanks on behalf of all fellow participants to you, sir. Thank you.